All right, cool. Well, I'm glad to be back, everyone. And thanks, Angela, for doing last week's. We're going to get you to do another one, I think. Uh, um, all right. So I think, well, hopefully at 6:07, you're starting to dig into this stuff. I presume Andy's largely using the tidyverse syntax at this point. Am I inaccurate in that? Um, um, so I like this slide, and I only point out the left-hand column because I am old enough that I learned R before tidyverse existed. And so I will, on occasion, slip into, sort of this dollar sign notation. There's some interesting debate on Twitter about all this. There is actually one prominent R user who, for some odd reason, seems to make it his mission to kind of sort of push against the tidyverse, but Hadley has a great tweet. I could probably find it and post it on Slack later, but like you need base R in order to do everything, right? I mean, ggplots, tidyverse is written in base R, and I think it's just useful to be aware that both exist. I personally don't care what you use. You know, just use whatever's useful, right? I'm more pragmatic in this, so I try to use tidyverse more often because in my experience it's easier to read and understand. So it takes me a little bit longer to write code in tidyverse, but when I come back to modify code or rerun code, I find it quicker to understand what's going on than in base R, right? So it's often worth it to do a little bit of effort. But if I'm doing a quick one-off analysis, I will probably, and if I do some live coding, I end up doing sort of the base R tidy dollar sign approach more because it's just quicker and it's what I know. But I've seen people do tidyverse faster, so it's just kind of where you are in your learning path. There's also formula syntax, and we will use that when we get to modeling. So I'm not going to talk a whole lot in that middle, but there are ways of doing data manipulation using sort of a formula syntax. I rarely see it used, so I won't talk about it a lot, but we will use a formula notation in other places. We're going to talk about ggplot tonight too. So the other place where the formula notation comes in is in the lattice framework for plotting. Again, ggplot2 is pretty much the de facto standard, I think, in terms of plotting in R now. I mean, there are base R plots for sure, but so much is done in ggplot now that's really, you should spend your emphasis. All right. And so this plot or this figure is just trying to kind of give a sense of what these are. Sort of the big thing is when you use a dollar sign. So in all of these, we have like a data frame, and then the dollar sign allows you to reference a particular column or variable within that data frame. Right. So that's the big thing. But then you end up having, like, when you calculate means, all right, you have to do this kind of whole crazy thing. Whereas we're going to talk about the pipe operator in just a moment, which is we're going to kind of chain operations together. So let's talk about the pipe, right? So until fairly recently, within the last year, people were using this percent greater than percent. So if you have done any Linux programming at all, pipes are probably somewhat familiar, right? So the notion of a pipe is I'm going to have some very precise operation, right? Or I'm going to do some operation, and I want to take the output of that particular function or that operation and pass it to another operation. And so the idea is I can chain a whole bunch of things together to get what I want. In terms of like data analysis, right, we're often going to, we want to filter some data, then we want to select some variables, and then we're going to, create some new variables, and then do some other calculations, and we want to just chain these together. And so the pipe operator is how we did it, or how we're going to do it. And it's really, so this particular operator, it's technically a function, is part of the MagriDAR package. But if you're using a fairly up-to-date version of R, you can do vertical greater than. So there's actually a pipe built into R. You don't need to install any packages to use it. So you're going to see in our slide decks and some of our, and even in the labs, we're still using percent greater than percent. Slowly in the process of just replacing them all with this operator, since it's built into R and doesn't have any dependencies. There are some, I'll just say there are some edge cases where they're not, the R base pipe is not 100% compatible or give you the same result of that. But so if you see weird things, just be aware of that. But that's all I'm going to say. Why do I like it? The place where I was first convinced that the pipe operator is a lot better is in terms of contingency tables, or proportional tables, I should say. So to get a proportional table in R, at least in the base R, you have to call table, right? And so that gives me a contingency table, and I take the output of that and I have to pass it into the proportional table, and that gives me the percentages. So so in this case, we have in the Lego sets data set, we want to know, well, what proportion of each category what's the proportion of each category to the total number of sets available, right? So books are 2.87, right? That's ultimately what I want to know. And so you could do this, right? So it's either 2 lines, 2 operations, and we're saving this sort of intermediate variable, or you have this nested function call. And so this is one of those situations where reading this, I think, is a little bit difficult because you have to start on the inside, right? So we're pulling out the category variable from the Lego sets, passing it. So that goes as a parameter to the table function. The result of the table function then goes in the prop.table. So I hope you kind of get the sense of what I mean by it's if we're starting on the inside and moving out versus just reading left to right, right? So here I can say, well, give me, in fact, I could even simplify this and take this, pipe it in the table, pipe it into prop.table. I probably should do that. But I'm starting with the contingency table, and then I'm just piping the output, right? The left-hand side into the first parameter to the function on the right-hand side, right? And to me, and this is up to you, but to me, this is much nicer to look at than this, all right? So that's kind of the function and the value of pipes. And if you're in the R community, these are one of these pipes, depending on what people are using, is widely used now. And so you should at least be aware of them, even if you don't use them. Questions about that? Oh, yeah. I mean, RStudio has helped. I don't know if you're in here, let me log in. So matching parentheses can be a problem, but like at least nowadays, the RStudio IDE kind of tries to help you out a little bit. So if I put the cursor right to this closing parenthesis, it kind of highlights the matching one. But very quickly, using this approach where you nest functions within functions, you end up with 5 or 6 closing parentheses, and the openings are all over the place. And then you get an error message because you don't have the same number of opening and closing parentheses. So anyways, that's pipes. Is there a limit at how many items you can pipe? No, absolutely not. I was just looking earlier. I had an operation. It was probably like 10 or 12 lines. So what I tend to do though is I would probably put prop.table on the next line and then indent it. I find that a little bit more readable. So I don't know what script I'm looking at. This is a Shiny app. Do I have? Sure, I got too many files open here. Anyways, so that I usually have the pipe as the last thing on the right-hand side. The other reason I can do that is in RStudio, you can highlight a piece of code and execute just that line of code. So when I have lots of pipes, I do that, and then I'll go to here, and then I'll add in each incremental step. And so I can kind of step through it if I don't want to run it all at once, particularly as I'm trying to build up this chain of commands.
It does matter the order in which these commands or these functions show up, because I had problems these past couple days, or realization that that matters, right? So if sometimes your piping doesn't give you the outcome that you expect, then maybe moving these chain of commands around would help fix it.
Yeah. Karma has a question, a hand up.
Yes, Professor. So my quick question is that using the pipe operator, so I've never used Margaret R, and doesn't matter because mostly I've been using deploy R. It does have like different functionality.
So if you load the dplyr package, you're getting magritte-r.
Okay.
So magritte-r is a dependency for the dplyr package. So once you load dplyr, so in the dplyr documentation, they use the %, but it's not technically a dplyr function. It is technically it's in the magritte-r package.
Okay, got it. Thank you.
Yeah, and it is a function. So if we go here, so if I load magritte-r, yep. Okay, and how you can tell, right? So the rules in R, the rules is that variables and functions have to start with a letter, can't start with a number, but that's not really true because I can do, if I use this backtick mark, I can do % like that. And so you can see here, if I type something like mean, right, I can see the implementation of the function. This is a generic, we won't go into that. That might have been a bad example, but so if you type any function in R without the parentheses, you'll see the source code, or you can type view. What would be a better one? Let's try describe. Do I have, I might not have the psych package. Let me load. I'm trying to think of a function that's not generic. So if I say view describe, oops, right, I could see what the function implementation is. There's an edit too, so you can edit functions inline. All right, so if we type view backtick % greater than %, right, here's, so this is the source code. So it's really just a function. So let's take, let me load mtcars, oops, our good old friend. I should put this in an R script. And so I can post this later. So if we look at mtcars, we can look at the structure of mtcars, right? And what's gear? Let's look at gear, right? That's a great. So what I might do is I could say mtcars gear, and I'll use the magritte-r version. So just so I have this later, I will need yeah. Oh, I said magritte-r, right? Yeah. All right. So I could take that, pipe that to table, pipe that to prop.table. So when I run that, right, this is what I get, right? So 46.8% of the cars have 3 gears, 4 gears, 5 gears. And what I like, and so referring to before, right? So I can highlight just this part and I could get the contingency table. Right. And so I do this all the time just to kind of build it up. Now, what I wanted to show here is I could say, and this gets a little bit, and if this is a little weird to you, you can kind of ignore this. But if you're interested a little bit in the underpinnings of R, which is helpful to kind of be exposed to some of this for debugging purposes, right? I could say, so mtcars gear, I need the gear. And the second parameter is going to be the function. So you can see here, this is the function name. I have to put it in backticks because it's a non-standard name, function name, because it doesn't start with a letter. So in order to get to it, right, it can do that. Where this can get really crazy, and this is, you can save this for April Fool's Day. So we can look at, say, the plus operator. right? Which is really just a function. So I could say, right, so we're used to saying 2 plus 3, we get 5. But what we could do is it's a function with 2 parameters, and I could get 5. All right. You want to play a joke on someone, we can redefine the plus operation to be just something like, happy April Fools. So if I define that and I now go back and do 2 plus 3, I don't get the sum. I actually have now overwritten the plus operation, which would be a mean thing unless you're doing it for fun. And I have to now restart my R to get rid of that. So anyways, little digression, but could be a fun thing to do. So so all of those primitive operators are really just functions, right? Things are either vectors, lists, or functions. Those are sort of the main 3 types of things you're going to deal with in R.
Professor?
Yeah.
Quick question. So with the MT cars, so basically it was like a double pipe where you took the output of gear, you turned it into a table, and then
Yep.
you just pulled the properties of the table. So prop is a function.
Prop.table is a function. Yeah.
Okay.
Yeah. So if I do $prop.table. So yeah, so so the first parameter is a table.
Oh, okay.
So in the tidyverse, so if one of the books we have on our recommended list is R for Data Science by Hadley Wickham and Garrett, can't remember his last name. And the sort of tidyverse philosophy is that what we're typically going to do is chain together operations on a data frame, right? So, but you don't have to, right? The pipe works with anything. It's really saying, I'm going to take the output of the left-hand function and make it the first parameter in the right-hand function. That's really all it's doing. Was there a question? I thought I might have heard something, but maybe not. All right, pipes. That was longer than I expected. On this section, I'd like to go through fast because my presumption is you're probably learning a lot of this in 607. If that is incorrect, you can chime in and we can help out. Our goal is to get to a point where we start doing statistics. And so you might need to do some of this filtering, but a lot of the labs and exercises are going to just give you the data set more or less in the format that you want. But these are all the dplyr sort of verbs, if you will. So we think of these functions as verbs, as actions on the data. And so I love these little cartoons that Alison Hurst kind of created to kind of help visualize what's going on. So filtering is about subsetting your data set based upon some logical operator. Right. So the first parameter is going to be the data. And another thing I like about the tidyverse and the dplyr approach is when we start referencing variables, we don't have to do the $sign, right? So it's assumed that type is a variable in the df data frame. And when you get to base R, we would otherwise have to say df $sign type. And so here, and on the next slide, I think we have all the operators. So what we're saying here is in this data frame, give me all of the rows where the type is otter, and so ampersand is going to be our and operator. The site is bay. Okay. And so looking at if we have these 4 rows, we're going to keep the 2 that are in the purple box, right? So type is otter and the site is bay. This one here, the type is shark. So we're going to drop that. And this one type is otter, bay. Great. We have otter, but the site is wharf, not bay, right? So that's kind of how filter works. Operators though, right? So a key bit is, what are these operators that we're using? We're going to use explanation point is going to be the not operator. Basically take the negative of whatever you're going to get. 2 equal signs is the logical operator of whether or not these 2 things are equal. So you'll see me when I do assignments in R, right? If I want to say I want to take the output of 2 plus 4 and, assign it to A. This is how I do assignments. But it is correct to do this. This works the same, right? But I prefer this so that when I see an equal sign, I typically are going to use 2, and it's just debugging. It's just easier to see than using the equal sign. But that's personal preference. Some people still like to use the equal. This didn't always exist in R. This was initially the only way you could do assignment in R, and at some later point. I should also say, if you really want to take the chaining to the next level, let's take this. So if I wanted to save the proportional table, I can say, so tab is like this, right? I restarted my R session, right? Right, and then I could do tab. But if you really want to be a completist about this, there is another operator you can do dash greater than, right? If you want to keep the left to right, you could do it like this and we can still get it. I don't see very many people do that. I still like the assignment on the far left. Explanation equal is not equal, right? And then we have greater than or equal to, less than or equal to. This one's really useful. You'll see us use it a lot, percent and percent. It's like doing a bunch of ORs together, but with the vector. So letters is just a built-in data frame, right? So I can type letters. You can see it's a vector with all the letters. If I type it uppercase, I can get the uppercase ones, right? So if I want to know the positions of the vowels, right? So what basically I want to say, I want where letters is equal to A, E, I, or U. So the way this works is I'm going to say, okay, for each letter, is it equal to A or E or I or O or U? Okay. So this bit, and this, I should probably change this slide. So if I do this, right, I get a vector of true and falses, but I can pass that to the which command, which is, oops, why did that not work? Oh, all right, I forgot. I don't have a newer version of R, so I need to use the McGreed-R here. Okay. So which just pulls out the positions of this vector that are true. So we can see position, that's A, E, I, O, U. So we can see the positions of the vowels in the alphabet. Okay. So it's a bunch of ORs. It's really useful to subset data sets. So the vertical pipe alone is the OR operator. And as we saw on the previous slide, we use ampersand for and. And there is an is true function if you're going to use it. But so far, so good, I hope. So those are all the logical operators. So hopefully this is going to be a nice reference slide, perhaps. So when we get back to filtering and we look at our Lego sets, right? So if I want all the educational data sets that were released after 2015, right? I could say, here's my data frame, piping it to filter. And I'm saying theme group is educational, year 2015, right? And I get 61 results. This is how we would do it in base R. So we have to use this square bracket notation, right? And the way that works is we're going to have rows, comma, columns. So here, the first part is this is going to return a logical vector equal to the number of rows in Lego sets, where we have theme groups educational, years greater than 2015. And note I have nothing after the comma, and that means return all columns. Okay, so if you have nothing after the column, return all columns. So these do the same thing, and you can decide which one you like better.
Professor?
Yeah.
Just the first one. So why exactly are we piping Lego sets into filter? Wouldn't we just filter Lego sets without a pipe?
Yeah, I mean, that's because that's the first parameter.
Yeah, does it?
So that's a good question. I don't know why, but in that R for data science, this is kind of how they do it. They start with the data frame and just pipe it into the first function in the chain. You could just make it a parameter there. Here's one reason why, going to Angela's comment just a moment ago. Sometimes you might need to change the order of these operations. And if you do that, then you need to then delete that parameter from that first function, where if you just start this way, you can then reorder them and not worry about that, the data frame coming into the first parameter. Does that make sense? So let's look at, I have MT cars here. So let's look at that. Oh, I gotta load it again. Okay, so it's a small data frame, 32 objects. So let's say we want 6 cylinders and MPG greater than, I don't know, 20 or something. I'm just gonna make something up, right? So what I might want to do is say MT cars, and I'm going to filter and say MPG is greater than 20 and cylinders is equal to 6, right? Did I type something wrong? MPG, saying it's not found. Huh? Why? It's there though. What if I take that off? Does cylinders work? Do I get an error on that? So, oh, I know why. I restarted my R session. I didn't load dplyr. There we go. Okay. So now I'm going to mutate and say select MPG. Well, let me do it. Let me do it this way. So I come in and I'm going to say, what I really want to look at is MPG and weight, right? I'm going to leave that off. So the first thing I do, right, is I'm going to select and I want to look at MP and I go, well, but really what I want is, what I really want is this case where miles per gallon is greater than 20 and cylinders greater than 6. Now I have an error message, right? Because I'm trying to filter on cylinder, but I've selected it out. Oh, great. So that means I need to put that first, right? And so I can now rearrange it and I don't have to worry about the fact that that first parameter in the first function has the cars. So that's sort of my kind of clumsy reasoning for doing that.
Okay. But in general, like it's possible to just do it, filter, and then open parentheses Lego sets, and then do the rest of that.
Yeah, I should have the Lego sets here. So I could do, this is perfectly valid.
Okay.
But like I said, if I rearrange it, then I need to delete that and put it as a first parameter in the select. If I change the order.
Hear you.
Yep.
Okay, thank you.
All right, selecting. I kind of showed this, right? So in base R, right, you can just, if you want to select, and there's a whole bunch of other, if you look at the documentation, I would recommend, and I'm going to show a cheat sheet in a second. That was weird. Why did I get 2 S's? There's things like everything LASCAL starts with, right? So there's like patterns that you want to match columns. This is really, really powerful. Here, just a simple, these are the variables in the data frame I want to keep. I just list them in the select. Okay, so in base R, right, I'm using my square bracket notation. I want all rows, which is why I have nothing before the column. And then I create this character vector of the columns that I want, and they have to be quoted, right? So this is what, and here I'm just showing the first 4 rows. Same thing, you know, you pick your preference. Relocating, right? So if you want to move columns around, I don't do this terribly often unless I'm like creating a table for a publication or something, right? So here, but this is another place where dplyr is really fantastic. So I want to relocate and I want to put all the numerical columns after the character columns. So in dplyr, I could say, well, give me the numeric ones. That's what this, so where we saw that just a moment ago. So that's returning the positions where is numeric is true. So that's telling me which columns are numeric. And I want to position them after where the last character column. Right. So you can see now I have character, numeric, numeric, numeric. Right. Base R, I don't think there is a way you could do it, but it would take a lot of code. Right. So here, really the easiest way to do it is you have to know what the columns are. So you're going to look at the structure and do kind of the same thing we did for select, but now I've looked at them to make sure that they're in the order that I want them. So base R doesn't really have a nice way of doing this kind of relocation stuff. Renaming is also, this was one of the first things that made me start using dplyr, right? Because I do often want to change column names. I get a data set from somewhere. The worst is like educational data sets because the variables are nonsensical. So luckily I have a big monitor. I usually have a code book and then my R and on side by side, I have to go through. And so, you know, column Z1451 it corresponds to ethnicity, right? So I need to rename that because that, you know, that's literally how variable names come in some educational data sets. So the way this works is, so that you have the new, you say rename. So it's your new variable name equals your old variable name. And it just matches it and it does it for you. In base R, you can use the names function, right? So that returns the names. It's as a character vector. The 5th column is the US retail price. So I have to know which position it is. And I'm going to change it to US dollars, right? This is so nice if you need to do batch renaming. Question? Yeah, Matthew?
Yeah, I definitely am understanding everything except for the head and equals.
Oh,
I think I'm just missing that.
okay, good. I'm glad you asked. Head is pretty simple. Head by default returns the first 6 rows. Okay. There's a similar function, tail, that returns the last 6 rows.
Now I remember. I'm sorry, I completely forgot.
But there is a parameter n, right? So you can say n equals, I guess I said 3, right? So that just returns the first 3 rows. So I do this because I can't fit the whole data frame onto the slides.
It's a good way to see whether or not there's anything funky with your data set, just like a quick glimpse.
Yeah, there's a glimpse function that I should use, but I don't. I just still use head. This is one of those cases where I slip back into base R from the tidyverse.
Professor, so the the USD is the new name, US retail price is the old name.
Yep.
And then why are we I have 2 questions. Why are we calling dplyr, and why are we piping into head? Shouldn't we be able to call the function without using dplyr?
Oh, this? Yeah, you could, if you load the package, this is not necessary, but it's increasingly becoming recommended. So the way this works, if you've done any other object-oriented programming, a lot of times you have to have, and it's usually with, I was Java, but it's been a while since I've done Java, you usually have like package, you know, or you could do the package reference to get to the function name, but it would probably be a method. But anyways, this is just the way to say, I want the rename in this. And so I actually just encountered this before. One of the reasons why you might want to do that is, let's take select. Okay, so it came up with the, was it select or was it filter? Yes, it's filter. There's the filter in dplyr, And then there's also a filter.
Oh, and other packages.
Yeah.
Oh, so you want to use it so people who are reading your code know where it's coming from?
Yeah. I really want the rename function from the dplyr. There might not be another rename, but there could be.
Yeah.
So
I see what you're saying.
that's why it's recommended now, because it didn't matter so much when I first started, because at one point I actually kind of knew every package that was on CRAN when there was like, I remember when there was a kind of an email thread going around. It's like, there are 500 packages on CRAN. Can you believe it? I think there's like over 20,000 packages on CRAN now. So the likelihood of having naming, would be called a naming collision.
Yeah.
Is increasing when you have 20,000 packages. So
It's like having a classroom with 2 kids named Bob.
yeah, exactly. Right. Yes, exactly. So it is not necessary, but if you don't do that, it's
Get a name.
it's the last package wins that was
Okay.
loaded.
So Dipler rename, so we have the package, the function, and then we're
Yep.
changing the name of the column. And
Yep.
why are we piping it into head n equals 3?
Because I can't fit any more than 3 rows on the slide. Otherwise it wouldn't fit. So
Oh, okay.
typically you wouldn't do this, but in order for me to get to look at it on the slide deck, I can't have all the rows.
I hear you. But you have to know the exact name of the column that you're replacing.
Yes. Yep.
Okay.
Versus in BaseR, you need to know the position of the column. And this gets really dicey, particularly if you're trying to create reproducible or reusable code.
Yeah.
Because, if you get an updated data set and it's not in the same order, you're hosed. Because it'll do the rename, but it may not be US dollars that's in that column anymore, right? It could be
Yeah.
something else. And then you go to use it to model and, anyways. So really use the dplyr rename.
Thank you. Okay.
If you were to reverse the order of the rename and the head, would you then just get the head listing with the old name, US retail price?
No, I think that would work. So if we say, let's try it with MT cars, because that's what I have here. So if I say MT cars head n equals 3, and I say rename, I said it would, so miles per gallon equals MPG. Okay. I get the same thing in this situation, as I want, so these are going to result in the same thing. Now, what's subtly different, and this is where you can say, well, let me just look at the first. So I'm truncating the data frame to just the first 3 rows. So the rename is technically only renaming 3 rows, right? Versus this, I'm renaming the column. Well, I mean, I guess it's in the case of a column, it doesn't matter. So I rename the column, then take 3. So in this case, the order doesn't really matter, but in some situations it could. And like I said, typically I'm not doing this. I'm just assigning it, to a variable. So a lot of times what you see is my, so I'll call it, say, empty cars 2 for lack of creativity. So I might do that and then just say head empty cars 2. All right, that did what I wanted. And then either I delete this line or I come in and I comment it out as we go. Oh, my video turned off. That was weird. Sorry about that. Is that I can't remember who asked the question. Is that
Crystal.
Crystal?
Yeah. So you're saying that it would just rename it for the head and it doesn't actually rename it in the data set
Yeah.
in the first one? Okay.
All of this, you would need to assign the output to something to keep it. So
Okay.
here I'm doing the renaming only for printing. So in the in the case if I'm making a publication or creating a slide deck that I'm going to present, a lot of times what I do, so as you're learning with R Markdown, I often create a lot of my presentations in R Markdown, but I make them pretty so people don't know it's created in R. Right. So I can turn off so you wouldn't see this code, that you would only see the output. And so that's a case where I might do something like that. So I could say, in that case, there's a parameter in the R markdown that says, you could say echo equals false. So this code would be executed, the output would be shown, but you wouldn't see the code to create it. I know this is a lot, so you're going to get more exposure through the labs and as we move through the course. So this is a slide deck you might just want to have on the ready as a reference as we go through. And you can ask questions at any time.
Professor, one quick question.
Yep.
So is there any specific name for the double column sign that we are using after the dplyr?
This,
Yeah.
is there a name
Is
for
there a
these two
specific
columns?
name? Yeah. Is there any specific name for
I
the
don't know
double
what-
column?
Yeah, that's a good question. What is, I have to quote it. Language definition. We're going right to the index of prefix and infix and prefix. Would that be an infix or a prefix? I don't know.
Doesn't it take the place of like almost like the dot operator, like you were mentioning? It's like module, like, and then method call.
Yeah, I think Python uses the dot, right?
Yeah. There's
yeah.
a couple languages that do. It's kind of like that's like one way
Yeah.
to think about it. I don't like that one's just it's a dot, so it's called the dot operator. But I don't know.
Yeah. So yeah, it is
If I
really.
if I call it a double colon, is that okay? Or
Yeah, sure.
all right.
Because the dot does not have a special meaning in R, right? So you can have dots in your variable names and function names, and you'll
Alright.
see that. I mean, we already saw that prop dot table is a function name, right? That dot would cause issues in most any other language. So ours kind of, I still have dots because I used it for a long time, but I am trying to move to using underscores where I would have previously used a dot.
All right.
Okay, cool. Mutate. This is, I think, the last one. So this is one you want to create new variables calculated for another. So in this case, and here I'm actually chaining some pieces. So I'm taking our Lego sets. First thing I want to do, because I want to calculate the cost per piece for a particular Lego set. This is a common metric if you're in the Lego community. When people evaluate sets, it's like, well, what's the cost per piece in terms of value of a set? So if I'm going to do that, the first thing I'm doing is removing. So there's is.na. So that's a function. It's going to return true if the value of this variable is missing, right? So if the missing variable doesn't have a value, or it's NA or missing, then I'm going to take the not of that because I want to keep the ones that don't have missing. And I'm doing the same for the US retail price. Okay. So I'm doing that first, and I'm going to take the output of that and to the mutate. So I'm going to create a new variable called price per piece, and that's equal to the US retail price divided by the number of pieces. And sorry, just to make it fit, I just want to look at the first three rows to see if it worked. So we can see for this one, it's 41 cents per piece, 80 cents. This one's crazy, 14.9. I think the average is somewhere around 10 cents a piece, typically. And then in base R, which is, so the first thing is I just did that subset, then I'm using the $sign. So the $sign, pulls out a vector, and if that variable doesn't exist already in the data frame, R is just going to add it. It's just going to create it. So you can see I'm taking the price per piece and the retail price, but in this syntax, I actually have to have the data frame $sign. That I have to have that. So the nice thing about the mutate is you don't have to specify the data frame name when you're referring to each variable, because it's going to be whatever's passed in.
Professor?
Yep.
So mutate is basically just creating a new column, and there's some kind of a calculation where you're naming a new column, and that column is a composition, multiplication, division of two other columns.
Yep.
One thing I'm confused about is like the exclamation point is.na pieces. So we're looking for null values. So where is the price per piece coming from? If
Well, no,
these
no, no. I'm first filtering out the rows where
Oh,
pieces and
okay.
retail price is null.
Okay. I see what you're saying. Okay, yeah, and then you're taking the price per piece of everything that's not a null.
Yep.
Right, sorry.
Particularly pieces, because I don't want to divide by 0.
Yeah,
I'm trying to avoid that. That's the main thing I'm trying to avoid.
sorry, I got confused by that.
No
Thank you.
worries, no worries. Yeah. There is another operator that's there's NA and then there's an NaN, which is not a number, which is I think what you would get if you inadvertently divide it by 0 because it's undefined. Yeah, Karma.
Very quick question. So when when just for the scenario, right? So if we filter only pieces, right, and if we try to find an average for a US retail price, and what happens if in the column pieces, right, there's NA, right, as a value, but in US retail price, we don't have an NA. Does that column gets removed, or it still reads the value?
So
Doesn't make sense.
okay, let's look at it. We can do it this way. Let's say we can try it. So let's do some division. We can just look at the division because it's just going to do it row by row. So if I have 4 divided by 2, right? Just simple division, great. So if I say 4 divided by NA, I'm going to get, oh, that's not what I expected. If I do NA divided by 4, I get NA. So, oh, right. Okay, right. I'm sorry. That is what I should have known this. Okay, so if you have a missing value, so actually what I need to be doing is filtering out where pieces is 0, but there would be no set with no pieces. So, right. So if you have an NA in any operation, the result of that operation is NA. Okay. Now, where I could have a problem is if I do 4 divided by 0. Oh, this gave me infinite. That's not good. Usually I get NaN. And if I do 0 divided by 4, I get 0, right? Of course. I need to make a note. Why is this? Because I think if I do it so I have empty cars now, right? So let's, I'm going to put this back. So if we had empty cars, so I'm just going to say empty cars. Sorry, this is a case where I'm just going to real quick. So if I say row 1 miles per gallon is equal to let's say 0. Let's look at the head. Okay, so I have 0. Now I'm going to say empty cars to cylinders. I'm just picking a random column divided by empty cars to miles per gallon. It gave me infinite. Okay, so you stumped me. I thought it would give me NaN, which is undefined, because you can't divide by 0. That's not defined. So it gives me infinite. All right, I got to do some research. I'll get back to you on that. Sorry.
My question was a little different than that, actually,
Okay.
but yeah, I'm glad you find that. But when you have a row that has NA in pieces, right, and you have a value in US retail price, right? When we filter NA for pieces, and when we try to calculate the value for the US retail price of the same row, so the US retail price gets erased, or no, it does not?
Oh yeah, you can. I could have. Yeah, you can overwrite columns. Yes, absolutely. You don't have to create a new one. You could just recode a current one.
Okay, got it.
Yep.
Thank you.
Absolutely. Good question. Yeah. All right. So group by and summarize. So in this case, this is kind of a, doing group statistics. So here we're grouping by theme group, right? So this is a qualitative variable. And then I'm piping that to summarize. And so here I'm creating these variables. So I want mean price, which is going to be the mean of the retail price. Now note here what I'm doing is na.rm equals true. And the reason why I'm doing that is now I think, so let's go, let's change this a little bit. So now I'm going to change it to NA. If we look at head empty cars, we have an NA. So now if I say mean empty cars 2 miles per gallon, I get missing, because if there's one missing value present, it cannot calculate the summary statistic unless I am explicit and say RM is all right. I hope I got that. It's true. So what, I got it backwards. I knew it. NA.RM. So what this parameter is saying, well, remove the missing values and then calculate the mean. That's essentially what it's doing. Okay. So that's why I have that there. But you can see I'm using mean, standard deviation, median, N gives me the number of observations. And here I have a missing. So this is kind of handy. So is NA returns a vector of true or false of whether it's missing. Well, I can actually sum of a logical vector. So true becomes 1 and false becomes 0. So if I just sum that, it tells me how many missing values there are. And so this is what I get, right? Pretty handy. You will see me use quite a lot. These are 2 functions in the psych package. And the reason why I use them is in one line, I get really all of the kind of variables that I tend to care about. So I have N, mean, standard deviation, median, trim mean takes the lowest and top, the lowest 10%, the top 10% drop, cuts them off, and then calculates the mean. So this is useful if you compare the trim mean to the mean. If they're different, that's a good indication that the distribution's skewed. We'll talk about a little bit more about that in the coming weeks. Minimum, maximum, and then these are some skewness, and standard error we'll talk about a lot. But then there's a describe by, so I give it my quantitative, and I can have one or more grouping variables. And then again, it gives me everything. So this kind of replicates this, but it's a really quick and dirty way in sort of one line of code to calculate these things. So I still use this function quite a lot. Questions about that? Are you learning this stuff in 607 and hopefully a little bit more detail? Yes, no, not yet. Yes, yeah, I got a thumbs up.
Yeah, we're looking over this in 607.
Great. You're not going to need to do a lot of data manipulation in this class, not until probably your data project. And so hopefully by then, if you're doing these at parallel, you'll get more and more comfortable. So sorry to go so fast, but this is sort of kind of an aside for our course, but necessary. You need some of this to kind of be able to do what we really want to get to. All right. I know we got only 5 minutes, so if you can bear with me, I'd like to wrap this up tonight. So again, I'll go through this rather quickly. So if those who have to leave and drop off, I understand you can catch the rest later. But I want to talk a little bit about ggplot. Oh, is that Matthew just asked? Yeah, here it is. So, and I think I took out all the base plot stuff, and really I'm gonna try to use ggplot exclusively. So ggplot is a framework for data visualization. So this is based upon Wilkinson, I think in 2005, published a book called Grammar of Graphics. Yeah, 2005, it's right here. And then Hadley Wickham, as part of his dissertation work, implemented it in R. And I think it was actually just ggplot, but then did a rewrite and became ggplot 2. I can't remember exactly when it was released, 2008-ish or so. And now it's replicated in other languages. Like there's a Grammar of Graphics for Python that uses a very, very similar syntax. The idea here is we're going to build plots layer by layer, right? And so it becomes a really nice default framework to create, I think, visually pleasing graphs and often, visually appropriate graphs. There's three major ways to use ggplot. There's something called a qplot. And the goal of qplot was simply to have a one-to-one replacement to the base R function. So there's a function called hist, H-I-S-T, to create histograms in base R. And so qplot, there's a qplot to do histograms and just kind of replace it. We're not going to use that at all, because in my experience, it's worth building up the more formal syntax, because inevitably you're going to add a layer. And so if you start with qplot, then you just quickly move to option 2, which is we start with the ggplot expression, and we'll talk about what goes in that in a moment. And then you just build up these geoms and other attributes. Now, ggplot was implemented using something called grid graphics, which, so with grid graphics, you can actually then get in and manipulate the actual parts as they're drawn to the graphics device, which is often your screen, but it could be a PDF or a JPEG or whatever. And so that's what the third option. So there are, layers. It's really just layers, but the geom is what we're going to do. So we're really going to focus in on this and just work with that. So the parts of a ggplot expression. So you start with ggplot, which defines the data and the aesthetics, right? So the first parameter is your data frame, right? What data are we going to draw from? And then you have this AES. AES is short for aesthetics, and you're going to define the components of your graph. So very often you're going to have an x-axis and a y-axis, right? But as you're going to see, we can have other things like color and shape and size and line type. There's a lot of options that you can go in there that can manipulate that. So that's the base. You got to define your data and then map the columns in your data frame to components on your plot, right? Then you're going to add layers, right? And they all start with geom underscore. So you have, if you want a point, there's points, there's histograms, and in a moment you'll see there's a lot of things you can create. So probably in a large set of your cases, you might only have these two pieces, and that gives you a perfectly usable plot. But you can do some other things. So faceting is a way of creating sort of subplots based upon some other variable, typically a qualitative variable. So we want to wrap it, so to have a different plot for, in this case, we're going to use this data set called diamonds. We'll look at it a little bit more in a second, but there's a variable called cut, right? So we want to have a separate one for cut, or we can do it as a grid. Right? These are the two main types of faceting that you can. You can rescale stuff if you need to. I almost never do this. So as we'll see later on, when you have skewed distributions, you might want to do a log transformation. I generally do my log transformation before I get to the plotting phase. So I might create a log version of a variable. But anyways, you can do it directly in the plotting. And then there's other options like manipulating the title, changing the limits of the X and Y axis, changing the labels of the axis. So those are the pieces that we're going to use to build up this ggplot. So here, someone was at the outset was talking about regular expression. So here, I actually used the grep function to get this. So I'm looking in the ggplot2 package. These are all of the geoms that are built in. And then there's extension packages. In fact, I wrote my own custom geom for a 2D box plot that I could show at some point. So lots of people have written packages to create other geoms, but these are all the ones that you want. So you could look at this list. And then generally what I recommend is you find one you like. I go geom, say I want a histogram. I do question. Oh, I didn't load ggplot2. Do question mark. I often go right down to the examples and start running them and manipulating them and see how they fit with me. Okay, there's a cheat sheet. Highly recommend having this available. It's kind of nice. So we're going to cover a lot of these things. So let's just look at, I find it's nice to look at some examples. So here with our Lego sets, let's do a scatter plot where we have pieces on the x-axis, retail price on the y-axis. Ooh, I skipped the plot. I'm sorry. Here we go. Right. And that's it. And then we're going to do geom point. So here we are. We created our first scatter plot. So we could kind of see there's a nice linear relationship between number of pieces and the retail price, right? Not many sets with large number of pieces, but there's some out there. Now I want to, color the points based upon the availability. And so it automatically gave me a legend. So you can see educational, right? That's what some of these, I think, big ones are. Anyways, so we added another component. So we were actually looking at 3 variables here. And this is all we did is we had to add this color parameter in the aesthetic. We can go a step further. We can make the size of the point correspond to the number of minifigs in that set. So bigger dots mean more minifigs. Okay. So pretty easy. We could kind of build this up. Let's look at this different, this is where the facet comes in. I want a separate scatter plot based upon availability, right? So looking at the color, because there's so many points here, purple must have been drawn last. I can't really, differentiate what's going on down there. Well, let's separate it out so we can see, all right, here's the exclusives. We have not specified, retail. And, from this plot, right, we can see education, not sold, right? Legoland exclusive, promotional. There's not too many of those, right? So there's a couple of categories that dominate. But now I can tease out what's going on down here, right? What's retail and what's, retail limited or not specified. And this is all I had to add. So if we want to do box plots now, this is one little thing I find a little quirky about ggplot is I have to have an x variable to do a box plot, but I only want to look at one variable. So I can actually just create it as a constant. So you can see the x is equal to Lego. And what I really want to look at is retail price. And so we haven't really talked about box plots. So the way box plots work is the box is the interquartile range. And this one's kind of hard, but the bottom of this box is the 25th percentile. The line in the middle of the box is the median. Then this is the 75th percentile. Then you have this tail, which is 1.5 times the interquartile range. And then you put a point for anything that falls beyond that. So this is a way of detecting outliers. Doesn't make a lot of sense here because of the distribution is pretty skewed. We can kind of see that from the scatter plot, right? Things are kind of clustered down there. I rarely do a box plot with just one. I kind of want to look at it by some grouping. So here now my X is an actual variable in the data set availability. And so now I have a separate box plot of US retail price based upon each availability. Here's an option. Chord flip sort of rotates, right? So the only difference here is I'm adding this chord flip, but now I rotate it. I tend to like my box plots like this so I can read the labels. Histograms work very similarly, except histograms are unidimensional, right? So I'm only going to have an X and it's going to do the binning for me. Geom histogram. So we can see here's the US retail price. Again, we see it's positively skewed. We can add the scaling here if we want to do it. Oh, I'm sorry. And so we could kind of see we do a log transformation. It looks a little bit more normal. Is it Prinon? Am I saying it correctly? You had a question?
Prinon. Yeah,
Prinon.
professors. So basically, is there any way to easily label the bins? Because I don't want to add axis or tick marks in the x-axis. Rather, I would just have the program do it automatically for each bin.
Where on which plot are you talking about?
Histograms.
Oh, yeah, there's a parameter to the histogram. Yes, you can do it. I think it's bins. It's just a parameter.
So it's illogical. I would have to say true.
Oh, wait, I'm sorry. Maybe I misunderstand your question. So by default, I think ggplot creates 30 bars. So the bins changes how many bars you're going to use. But you're asking, I'm not sure if I know what you're.
Okay, I'm asking, so basically, let's say you look at the bins, but you don't know the upper or lower limits, right? They're not labeled.
Yeah,
So
yeah.
Is there any way to
Typically,
label them easily?
I don't know off the top of my head. If you shoot a question, I can look it up. you may want to bar plot and kind of cut them ahead of time if that's what you're interested in. I've not seen anybody label a histogram because it would get pretty messy pretty quickly.
Okay, gotcha.
So I'm not sure that's exactly what you want, but if you want to quantify or make a qualitative variable from a quantitative variable, so you predefine the ranges, yes, you can do that. You would use a combination of the cut and probably breaks command. So if you do !cut, you'll see some examples in there.
Okay, thank you.
Yep. We can wrap histograms. Okay, density plots I like a lot. So these are, again, these are the retail prices highly skewed, but we're going to look at if I wouldn't worry about it too much, because as we start doing some of the modeling and inference stuff, we're going to look at a lot of histograms and a lot of density plots. So you'll get more familiar with these, and we'll show lots of examples as we go through. I like this little cheat sheet a lot. I'm trying to zoom in. Well, that went too far. Can I bring it down a little bit? Okay, so what this little cheat sheet has is on the, I guess this is the Y, are all the geoms that you might want to have. Then the columns are the aesthetics, right? And the way this is mapped out is if it's a blue dot, that aesthetic is required. Okay. If it's a yellow rectangle, that's an optional aesthetic, right? So if we look at, well, let's just look at, I was hoping point would be closer to the top, but it's not. Maybe I can zoom out a little bit more. Why are you not zooming out? Come on. Oops, too far. Maybe this is okay. So if we look at point, put it right at the bottom. Okay. So X and Y are required for points to work. But as we saw, we could have a group, we can change the color, we can change the size, we could change the line type, we can change the alpha, which is the level of transparency, we can change the fill, and they could be assigned to either constants or other variables. Points can also have, so what is this? Oh, shape, right? So that'll change the shape, and stroke, which I think is the weight of the point as it's drawn. So this is kind of a nice little way to kind of figure out, well, what aesthetics are available for a particular geometry. So you might want to have this, you can print it out. And was it created in ggplot? Quite likely, but I'm not sure. I didn't create this one. I stole it off the web. I just found it useful. Anyways, and it's also color coded, right? So you could see the blues are the aesthetics, and you can actually, and as we go through and get more advanced, I don't want to get too crazy. You can change data sets on different geometries and combine them to create some really complicated stuff. All right, we're already 10 minutes over. We'll come back to Likert scales. All right, dual scales. Actually, we'll talk. I'm going to move this slide anyways to when we talk about z-scores. I'll just end the night on this, which is pie charts. This will be the only pie chart you see in this class. There's only one pie chart in the textbook, and I think there's a good reason for that. So this is an example I pulled off Wikipedia. And so just real quick, can anybody tell me what the relationship between the pies charts A, B, and C?
Are they exactly the same?
They look exactly the same. I would agree. They look very, very similar.
Maybe the colors represent different groups.
Well, sure, the colors represent different groups, but
Yeah,
is there
I
any
think
pattern?
the proportions are different, but it's very difficult to read. I think the red in the A is smaller than
Yep.
at least the one in C, I think.
Yeah. Would it be easier to see it this way?
Oh, yeah.
Right. So I am honestly, I have very few absolutes in life, but this is one of my absolutes. Do not use pie charts. And this is a famous quote by John Tukey, one of the preeminent statisticians of the last century, right? That there's no data that can be displayed in a pie chart that cannot be better displayed in some other type of charts. There's a lot of research on this. human beings cannot really, we're actually pretty bad at comparing area. And, you know, in pie charts, we're often not only comparing area, but we're trying to compare arc angles, right? They're not even straight lines. Is the length of this longer than this, right? And you see that with like donut plots where you just take the center out. Edward Tufte, another kind of proponent of data visualization, calls this, talks about chart junk, and it's about the amount of ink to information. And so pie charts are high chart junk because it takes a lot of ink for very little information. So anyways, just don't use pie charts. I know people like them and they use them in all different contexts, but there's always a better visualization tool, always. And you can send me, there are some fun memes out there, I will admit, like the pie chart of the pyramid, kind of like, but yeah, not going to want to do that. So we have a lot of additional resources. I know this was super fast, but we'll get a lot of practice over the rest of the semester. So you might want this. So the dplyr website, great documentation. Again, the R for Data Science book, it's free online. You can read it. Allison Hurst, who created a lot of those visualizations I used to kind of show the dplyr stuff, has a whole tutorial using the Penguins data set, which is kind of fun. And then there's the transformation cheat sheet. And then for visualization, there's the ggplot documentation site. Again, the R for Data Science book uses ggplot exclusively. There's our graphics cookbook. So this is a great place to look and or at least know what's in the table of contents. I want to do this. There's a good chance that there's a kind of a recipe in this cookbook to get you maybe 90% of the way you want to go. And then let's get the 1 minute papers into the chat. And we'll come back. Certainly answer other questions. I'll stay on if people have questions now, but crash course in data visualization and data manipulation. Ha! Yes, just don't use a pie chart. I don't care how neat the labels are. Please don't. And I would say that's probably one of the shorter rants. I kept it really, I could go on for a while. I put it at the end because I can fill the time if I need to on pie charts. But there's some good perception literature out there on them and why you shouldn't use them. So
is this section summarizing the data part 2 or probability?
No, this was part 2. We'll start probability next week.
Okay, got it.
Yep. So this should be lab 2, I think that's due Sunday.
Yep. Yeah, so you guys had 2 weeks to do this lab.
Yeah, believe it or not, we tried to do this in 1 week, in one lecture, which was always way long, and even splitting it in 2 weeks, it's way long. Yeah. But this stuff is really, honestly, this is really important. Like, just don't skimp on your descriptive statistics. Know your data, plot your data. You know, you're going to manipulate your data. Someday I want to do an analysis. I keep saying I want to do this. I want to analyze my R scripts. I have a lot of R scripts on my computer now. I dare say 80 to 90% of every R script I do to, you know, for whatever analysis I'm going to do is getting the data ready. So, and I know the first part of the semester is really hard because if I count all of the R functions you're going to learn this semester, you're going to learn 80% of them in the first 3 weeks. And then we're probably going to add 1 or 2 functions each week thereafter. Like when we get to regression, it's like two lines of R code once your data is ready. So I know it's a lot up front, but you'll get more practice. All right. Well, let's call it a night. We'll see everyone next week.
Thank you, Professor.
Thank you, Professor.